Okay, guys, let's begin. So before we continue talking about function, let me just take a step back and look at the homework problem. This is about what we discussed last time, just to make sure that this idea, this notion of a function, is okay with you, and that you understand the language. Okay. So let's just do this problem together. Okay, so here we're given a function. So remember, functions can be presented to you many ways. They could be given as a formula or via a graph. Okay, like over here. We don't know what the formula of this is, but we basically have a lot of stuff. We can get a lot of information out of this picture. So let us answer some questions. And here the point is to be able to understand what the question is asking. Okay, so you know what to answer. All right. So the first one says, what's the domain of this function? All right, so should I include negative a?
Yeah.
Okay, good. So that will be negative a comma infinity. Okay, good. Everybody okay with this? Remember, you have to look at the x-axis for this. How about the range? Yes?
Bracket 1, comma, negative infinity.
Think about what you just said. Yes?
Negative infinity, comma, 1.
Very good. So remember, numbers are written left to right, right? So negative infinity is all the way to the left. In this case, it would be bottom to top, right? Because you have to be looking at the y-axis. So you go down to negative infinity all the way up to 1. That's the highest point of the graph, okay? So that would be negative infinity, comma 1. Okay, good. Let's see, the next one. So what is or are, maybe there's more than one, the x-intercept of the function. If your answer in coordinate form, in other words, x comma y, okay? You cannot just put the value of x, you have to give whatever comma 0, okay? Separate multiple answers with commas as needed. Okay, so we're looking for x-intercepts. Anybody tell me what are the x-intercepts? I want somebody else. Let's see, in the last row, can you, any one of you, can you tell me what are the x-intercepts? Yes. Okay, as another pair, what would they be? Okay, no, when I say other pair, I mean the point. So what is this point? Negative 1, comma 0. Right? And what's this one? 3, comma 0. Good. That's what you need to answer here. If you put negative 1, comma 3, then it's not going to work, right? Because it's telling you to enter an order pair. So, negative 1, comma 0, and then 3, comma 0. Questions on x-intercepts? Okay. Now, D. It says, what are the zeros of R of x? Now, who can tell me what do we mean by this? So, what do we mean by zeros? Anybody?
The y-axis.
No. Yes? Very good. This is just another fancy way of asking you for the x-intercept. So basically, the answer here is the same as the one above. Okay? So remember, the zeros of a function, what we are asking is, what should x be so that this is equal to 0? That's another way of saying, give me the x-intercept. Okay? So sometimes you're going to see the zeros of a function, that's the same thing as x-intercept. Okay? Values of x that makes the function equal to 0. When the function is a polynomial, we also use the word roots. Okay? So the roots of a polynomial, the zeros of a function, the x-intercept, all of those are the same thing. Okay? Different ways of talking about the same idea. Now, typically, when we talk about the zeros, we mean the x, the value of x that will make the function equal to 0. So here you don't put a point, you put the actual x value. Okay? And if we click here, it should tell you what is expecting. So you see here, expecting a list of integers or decimal numbers. In other words, they don't want to see order pairs. Okay? So if you put here negative 1, 0, 3, 0, you're going to get it wrong. That's to put negative 1 or 3. Okay? In this case, there are two x-intercepts, so that's negative 1 and 3. Do you understand this? Okay. So remember, this is a language. Okay? These things are pretty straightforward. and easy in this kind of situation only if you understand what the question is asking. If you don't know what the question is asking you, then you don't know what to answer. Okay. Okay. So E, R of 3. Okay. So how do we find that? What are we supposed to do to answer that question? Yes? Okay, so what will be the answer?
It's
0, right? So when you see R of 3, what it's asking you is, okay, when x is 3, tell me the y. In this case, you can easily read it's 0. And in fact, it was one of the zeros that we found, right? So we better get 0. Okay, good. How about R of 9? Make it bigger. Let's see, who can tell me? Yes.
-6.
All right, so here is x equal 9. So we go down to whatever the function is, in this case down here, and we read off the y bar, right? So -6. So remember, what that means is that the point 9, -6 is on the graph, okay? That's what it means to say that R of 9 equals -6. Okay, good. So, next question. Is R of -5 positive, negative, or 0? Bring up the picture. What should be the answer? Negative. Very good. In other words, R of -5, that we're talking about the y value corresponding to -5. So to answer the question, you need to figure out, okay, that corresponding point, is it above or below the x-axis? Or maybe at the x-axis, okay? Remember, below the x-axis, you have negative y's, above you have positive y's. So in this case, R of -5 is down here, so it's a negative. You understand this? So it's negative. Good. So it's negative. So then, how many times does the line y equals 0 intersect y equals R of x? All right. So what's the line y equals 0? What's another name that we give to the line y equals 0? Which one is it? There's a specific line which is the line y equals 0. Yes? Very good. That's another way of talking about the x-axis. Remember, y equals a number, it's a horizontal line. For example, y equals -3 will be this line passing through y equals -3. Okay? Y equals 0 is another way of talking about the x-axis. Okay? All right, good. So how many times does a line y equals 0 crosses the function R of x? How many? 2 times. Do you understand this? Okay. So how many times? 2 times. Okay. Next. For what values of x does R of x equals -3? In other words, here we're solving an equation. Okay. All right. Okay. So what will be the solution to this equation? So we're solving the equation R of x equals -3. What's the solution? Let's see. Last row over there. What will be the solution?
-3 and 6.
Okay, -3 I agree. 6 I agree. Do you see any other solution?
Oh, it's -7.
Very good. So in other words, notice that here basically what we are asking for is, this is the line y equals -3. We have our function. To ask when R of x equals -3 is to say when does this line crosses this graph. Okay? So when you set 2 functions equal to each other, what you're looking for is the point of intersection. Okay? The places in which the 2 graphs cross. So in this case, here is your line y equals -3. So you want to find what are the x's that give you -3. So that happens at 3 points. Here, which is -7, -3, and 6. Does everybody understand this? Okay, that's what it means to solve an equation, okay? You're just finding when the 2 functions meet. Where do they intersect? In this case, we're solving the equation, but now what you used to do, like move stuff around, there's no need to do that because we don't have a formula. But we have everything we need. We have the picture. So three solutions: -7, -3, and 6. Okay. So -7, -3, and 6. 7, -3, and 6. Are there any questions? Okay, good. So, J, give the intervals of x such that r of x is greater than 0. So we want now to solve an inequality. So here we solved an equation. Now let's solve an inequality. Okay. So use the union symbol if needed. Okay. Who can tell me? This time we have a graph instead of having a formula. So who can tell me in plain English what is it that we are asking here? About that graph. What is it that we are asking? Yes?
From what x value to what x value is the graph above the x-axis?
Very good. So remember, greater than 0 means above the x-axis. Okay? Less than 0 will mean below the x-axis. And well, equal to 0 is at the x-axis. Okay? So in other words, here, just look at the picture, and your answer has to be whatever, whatever intervals the function, the graph is above the x-axis. Okay? So let's see, how many intervals do you see in which the graph is above the x-axis? Yes? Okay, and what is it?
Within parentheses, -1, 3, close parentheses.
-1, 3. Good. Does everybody understand why we're using parentheses? Okay, good. So -1, 3. So it's here. And then for the last one, give the interval for which the function is less than or equal to 0, less than 0. So r of x less than 0. All right. So what is it?
Bracket -8, -1 parentheses,
Good.
and then union parentheses 3, algebra parentheses.
Very good. So again, remember, whenever we're asking all of these questions, we are interested in x, okay, not in y. We're talking about x. So for what values of x, in this case, is a function below the x-axis. So you have to focus on the x-axis, and then you want to pick the portions of the graph that are below the x-axis. That's how it needs to be negative, okay? So -8 to -1. Include this guy because a -8 are down here, so that's fine. We don't include this one because a -1 is equal to 0. We don't care about that. We want less than 0. And then the other pieces from 3 to infinity, it's not including 3. And then all the way to the right, the function goes down. So that's what we get. Are you okay with this? All right, good. So remember, this is a language, okay? So -a, -1. Union 3, infinity. Okay. Good. All right. So, are there any questions on any of this? Okay. Good. So with this, then you should be able to answer questions about function and so on. It's just that, for example, in this case, it's just whether you really understand the ideas or not. It's just looking at a picture and answering the question. Typically, what happens is that you actually have a formula instead of a picture, and then you need to answer similar questions like this. Okay? There are some things that we have not discussed yet, like for example, if I give you a formula with what we have discussed so far, as long as it is a reasonable function, you should be able to do all the way up to I, say. But then for J and K, we need to talk about nonlinear inequalities. Because we only have discussed linear inequalities. We will do that at some point, and then you'll be able to answer this too. Okay, when a function is below or above an x-axis. But we will get there in time. Okay, good. Are we okay with this? All right, so then let's continue without discussion of functions. So now that we know what a function is and so on, it's time to start looking at some particular properties a function have. And then, as I mentioned before, the domain is a very important idea. So given a function, the first thing that you want is to be able to compute or to find its domain. Now, given a graph, this is straightforward. So the idea is, if I give you a formula, can you figure out what the domain is? Okay? So let's talk about this. Okay, so domain. All right, so let me start with a small question to actually illustrate the idea, the kind of thinking that you should have when you're looking for the domain. Okay, so question. So consider the function 1 over x. This is a function, right? Remember, for something to be a function, in this case, you have a formula. What it needs to satisfy is that given an input, there is only one output associated with it. Okay? So this receives the number, and the output is flips the number, 1 over that number. Okay? The reciprocal. This is called the reciprocal function. And then the question that I want to ask is, okay, given this function, what are the values that x cannot be? In other words, is there a value that we are forbidden to plug in into this function? Okay? That's what we're trying to figure out. So what is, well, let me just say, what is or are the values that x cannot be? You know, sometimes it can be whatever you want. Like, for example, if I would have said f of x equals to x, you can plug in whatever you want, right? Now, sometimes the formula itself comes with some restrictions. So in this case, what would be the answer? That would be 0. Very good. So answer, well, whatever we do, x equals 0 is not a good input for f. Why? Why is this not a good input for the function f? It's undefined, right? So remember, to be a function, given an input, you have to receive an output, okay? If you plug in 0 here, you're not going to receive an output. You're not going to get any number back. Do you understand this? You cannot divide by 0. So the thing is, because division by 0 is not defined. Since 1 over 0 is undefined. Okay? So this is the kind of question that you need to ask yourself when you're trying to figure out the domain of a function. Okay? So what are the values that x, in this case x because that's the variable that we're using, but if you have another independent variable, it will be that one. So what are the good values for the input? So usually there are infinitely many good values. Like in this case, let's turn the question around. What are the good values for this function? What are the good values for x? Exactly. So any real number other than 0. So typically there are a lot of numbers that are good. So what we want to ask is the opposite. What is not good for the function? Sometimes, you know, most of the time it's 1, 2, or 3 numbers or a whole interval. And then the good ones is everything but the bad ones, of course. Okay. So the domain of a function are the good values for the function. In other words, the values of x that you're allowed to plug in. That's what the domain is. But to find it, we usually ask the other question. What is not good? In other words, what is not in the domain? Okay? Like in this case, x is not a good value, so any real number other than 0 is a good value for x. We call this the domain of f. Okay, and in this case, we would write, you know, all real numbers except 0. So that would be the domain of the function. Okay, so let me define the notion of domain, and then, you know, this is the kind of game that you want to play. So given a function, you will have a formula, and the question is, what are the values that x cannot be, if any? Sometimes anything is okay, all right? But sometimes there are some restrictions. Now, there are some specific forms that we typically ask some particular questions. Like, for example, here, what was the defining property? What was the idea that we used to figure out that x equals 0 is not good? Why was this not good? Because that would make the bottom equal to 0. So in other words, when you have a function, if you see a fraction, one question that you immediately need to ask yourself is, okay, I cannot have the denominator equal to 0. So whatever x makes the bottom equal to 0, that's an issue. You have to remove it. Okay? Now, there are other type of expressions that may show up, like square root. For example, if you see square root, what's the red flag there when you see a square root? Yes?
You'll get pluses, minuses, two solutions for every
Okay, no, it's a function, so giving an input, you are only expecting one output. We're not solving an equation, this is a function.
So if there's a square root, you got two solutions. So
No, what's square root of 9? If I write it in symbols, what is the answer to this? What is this?
plus and minus 3.
No, that's 3. It's different. So this symbol means give me the positive square root. If I ask you in words, square root of 9, I just want a number whose square is 9. Then you can give me positive or negative 3. But this symbol is used to talk about the positive version of that. Okay? So this equals 3. So you understand this? Okay. So it's different when you have something like this. If you're solving this equation, then the solutions are whatever, when you square it, give you 9. There you get your plus or minus 3. That's why we actually put it manually, right? So you put this guy, but this is only the positive version. So you need to manually then tell me, I also want the negative. That's why we put it outside, okay? But this is just one thing. So when you have a square root, what's a red flag? Remember, when you have a fraction, the red flag is the bottom cannot be 0. Okay, that's your red flag. How about square root? If you see square root, what's a red flag?
Whatever something to the square root cannot be negative.
Exactly. So remember, here we're talking about real value functions. So we are not dealing with complex numbers. We don't want functions that give us complex numbers as an output. Okay, that's a whole different story. So in this case, we are only restricting ourselves to real numbers. So when you have square root, as you know, you better have something that's 0 or positive, right? Inside square root. Because if you do square root of something negative, it's not going to be a real number. And we don't want to deal with that. Do you understand this? So when you see a fraction, a red flag is, okay, bottom cannot be 0. If you see a square root, a red flag is stuff inside the square root cannot be negative. Okay? So using these ideas in mind, you can then find the domain of many functions. All right, so let me actually, number 1, then question number 2, here we have f of x equals square root of x. Find its domain. So what's the domain for this function? Wait for somebody else. So what's the domain for this function?
0 to 30.
Greater than 0, right? So 0 to infinity. Remember, like what we just said. What is not good? Remember, domain is what are the good values for x. So if you want to find domain, you need to figure out, okay, what's the problem? Is there a problem with this expression? So what's the problem with these kind of things? When you see square root, stuff inside cannot be negative, right? Therefore, the domain is the opposite of that, which is 0 or bigger, okay? So x has to be greater than or equal than 0. So domain, the point is that x, stuff inside the parentheses better be greater than or equal than 0. So the domain is from 0 to infinity with a bracket. Questions? All right, so let me define domain and then I'm going to give you some problems for you to work on. So definition, let y equal f of x. I mean, we already know what domain is. We define it at the level of relations. Remember, domain was just the collection of the first order. You just take the first element for each of the pair and you make it a set, okay? So given a function, remember, a function, you can think of this as a set of ordered pairs. So in this case, our ordered pairs would be the graph of the function, which are pairs of the form x comma f of x. Okay? So the way to think about it is the domain is just you pick all these x's together. But yeah, what are these guys? Well, these are the guys that we are allowed to include. Okay? So way to think about it. So I'm kind of redefining domain now in the context of a function, because we already had it defined in the context of a relation. So let y equal f of x be a function. So this will be an informal notion, okay? Because we already have the formal notion of domain. Then its domain is the set of good values for x. So do you understand what this informal notion is saying? You know, the good value for x, in this case, x represents the input of the function, the values that you are allowed to plug in inside the function. Okay? Like in this case, in number 2 here, we are only allowed to plug in non-negative stuff. Okay? In number 1, you are only allowed to plug in non-zero numbers. Okay? So that you could get an output. All right? So samples. Find the domain. Let's see, let's do f of x equals 2x over square minus 4 2x squared minus 5x plus 9 over x cubed plus 3x squared. X plus 1 over x plus 3. Okay, just gonna write all of them here, and then I do sum, and then you do sum, and so on. So the first 3, you know, you actually have only, in a sense, one type of problem. And in these 2, you only have also one type of problem. Now you could have a mixture of these things, okay? Stuff like this, in which there are 2 problems now that you need to take care of. Okay, so here we have 8 functions. Our job is to determine the domain of these functions, okay? Remember, domain stands for what are the good values for the variable. So let's tackle this one at a time. For example, I'm going to do number 1, then I'm going to let you do number 2, then we discuss number 3 together, okay, and so on. All right, so solution. Let's see, let's start with the first one. So, you know, the mindset that you need to have for this type of question, you need to find the domain. You know that what you want to do is figure out what are the good value for x. So remember, ask yourself what could go wrong with my formula. Look at the formula and think about what can go wrong. Just scan the whole function and then think about what could go wrong. Looking at this function, right? The top itself is a perfectly fine expression, right? Whatever x you give me, I multiply by 2. So the top is okay. The bottom itself is also okay. You can always do a square minus 4 regardless of x. Now, what's not good is the whole thing, because the whole thing is a fraction. So then you need to worry, okay, I have to make sure that this denominator here is not 0. Do you understand this? So at this point, I always like to write down the stuff that I don't want. So what is it that we don't want to happen in this function?
0.
What do you mean? So what is it that we don't want? We don't want the denominator to be 0, right? So we don't want x squared minus 4 to be equal to 0. Do you understand this? You know, now you solve it just to figure out, to see what is it that we don't want. Because the thing is that if you say this different than 0, it's kind of weird because it's not really an equation, right? Like, technically, that's not an equation. Equations have an equal sign, not equal sign. So that's why I don't want just to understand that this is really not equal to 0. Okay. Anyways, here you solve it however you want. The fastest way is just square root method. So of course, positive and negative 2 are not good for x. Okay, this is something that we don't want. We don't want x to equal positive or negative 2. Is there anything else that we should worry about in this function? As we said earlier, there's no problem. The top itself is fine, the bottom itself is fine. So, even if you don't have to, I strongly encourage you to just draw a picture of what you want and what you don't want, and then you will be able to answer the answer pretty easily. So here we have negative 2 and 2. We don't want those guys. How do we say that we don't want something when it comes to a picture?
Open circle.
We use an open circle. So open circle here, open circle here. How about anything else on this real line? Do we want everything else? Yes, right? So you just shade everything else. So now here you can easily see what the domain is. So everything that's shaded, of course. So there are 3 pieces in the domain. What are they? So what will be the answer here?
Negative infinity to negative 2.
So the domain would be negative infinity to negative 2, parenthesis,
U, negative 2 to,
union, negative 2 to 2,
and then 2 to infinity.
and then 2 to infinity. Okay? So you draw a picture, and the picture tells you exactly everything that's in the domain. Okay? And then it guides you how to write down the notation. Okay. Any questions? So remember, if you, for example, if you want to graph this function, what is this telling you? Remember, the object here is that we want to be able to eventually, we want to be able to sketch a graph or something like this. Okay? So if you want to do that, what is this information telling you? What does that mean in terms of the graph?
That negative 2 and 2 aren't values that
Okay, so what does that mean?
the domain is already on this besides negative 2 and 2.
Okay, what does that mean? In terms of the graph, what does that mean?
That it stops and starts and stops and starts.
So exactly. So this means that the graph, whatever the graph of the function is, it has to cover the entire x-axis, but we have to somehow skip this point, negative 2, and we also need to skip this point, x equal 2. Okay? But whatever it is, there is some picture going on here. There is also a picture going on in between, and there is another picture in here. So this graph is going to have 3 pieces. Do you understand this? Now we're going to see sometimes at these points that you skip, it could be that there is only just one hole in the graph and that's it. Or sometimes it's a little bit worse than that. Okay? As we're going to see, in this case, what's going to happen is that we're going to have a pair of vertical asymptotes here. So when the function is close to this point, the value should be either positive or negative infinity. Okay? So we have an asymptotic behavior. But we'll discuss that once we study this type of functions. They're called rational functions. Okay? This is a typical situation for rational functions. Okay, so but right now we're just worrying about the domain because given a function, you want to know what is it that you're allowed to plug in. Okay? So as long as you don't plug in negative 2 or 2, that's safe. All right, so next one was f of x equals 2x squared plus 5x plus 9 minus 5x plus 9 over x cubed plus 3x squared. So I'm going to give you a minute. So write down the domain of this function. Okay, so what do you get for the domain for this function? Okay, go for it.
Open parentheses, negative infinity, comma, -3, close parentheses, union, open parentheses, -3, comma, infinity, close parentheses.
Comma what?
Positive infinity, close parentheses.
Positive infinity, close parenthesis. Okay, is everybody getting the same thing? No? Okay, what do you get?
I took out, x squared at first,
Uh-huh.
from the denominator, so then I also got 0.
Good. So what will be the answer?
Negative infinity, comma, -3, and then -3, comma, 0, giving 0, comma, infinity.
Very good. All right. So again, here you have to be careful. Okay. So once again, scan the function, and what is it that we don't want in here? What are we trying to avoid? We don't want the bottom to be 0, so that means we don't want x cubed plus 3x squared to equal to 0. Then, keep looking at the formula. Is there anything else that could go wrong? Is there any other issue here? Another issue, right? I mean, the top itself is fine. You can plug in whatever you want, and then it will give you a number. The bottom also is fine. You can plug in whatever you want. It's going to give you a number. The issue is the fraction that cannot give you 0 in the denominator. Okay? But other than that, we are safe. So as long as we figure out when this happens, we remove those values, and then we're good to go. Do you understand this? So now the focus is solve this equation. So remember, when you solve a polynomial equation, the standard technique is you do it by factor. Okay? And actually, this is a cubic, so there is no other way to do this if not by factor. So in this case, we can factor out an x squared, so we get x plus 3. And you have to be careful. There are two solutions here. Okay? Remember, zero product rule. That means either x squared is 0 or x plus 3 is 0. So from here, you get 0 or -3. Okay? So these are two values that we don't want. We don't want x to be 0 or -3, because any of those two, you put it here, you're in trouble. Okay? You're going to get it in the denominator. So the domain will be a picture. So again, I don't want -3. I don't want 0. So do open circle. Everything else is okay. All right? And then your classmate said, that's exactly this one. Okay? All right. Questions? Any questions? Okay. Why don't you give it a try then to number 3? Let's see. Try number. I want you to do it yourself first, and then do it together. So try number 3. You write it down. So we have f of x equals 2x plus 1 over 1 over x plus 2. Okay. Anybody has an answer? Yes.
Negative infinity, comma, negative 1/3, close parentheses, union, negative 1/3, comma, 0, and close parentheses, and union 0, comma, positive infinity.
0, positive infinity. Okay, good. Anybody else getting something different? Did you get the same thing? Okay, yes or no? Did you get the same thing? Yes.
Wouldn't it like not have the 0 because it's only 1x?
Why is that? I don't understand the reason. So say that again.
It's only 1x.
Okay.
You can have x equals 0.
Can you have x equals 0 in this function? So you have to avoid it, right? I mean, remember, here the thought process is what's not good. I mean, what is it that you're not allowed to plug in, right? So again, don't modify this because if you modify this, you will get algebraically something equivalent, but you have to be careful. For example, if you want to simplify this, you will multiply top and bottom by x, like to cancel the denominator and so on. But the thing is that that's only valid as long as x is different than 0. Because when x is equal to 0, they're going to be multiplying by 0 over 0, and that doesn't make sense, right? So if x is different than 0, then you could do the transformation. But if x is equal to 0, you cannot. So you always want to work with the original function. So you scan this and you ask yourself, once again, what can go wrong? Well, now you should realize that there are multiple issues here, right? Two problems. First of all, there's a big fraction here. So this denominator itself cannot be 0, right? That's one thing that we need to worry about. But then also there is a little fraction here, so there's another denominator that cannot be 0. Do you understand this? So there are two issues that you need to take care of. After you take care of that, is there anything else that we need to worry about? Anything else? No, that's it. I mean, look at the top. The top is fine. 2x plus 1. X can be whatever you want as long as the top is concerned. And other than what we just mentioned, the bottom would be fine. Okay? So, if you want to figure out the domain here, again, there are two things that you have to take care of. So first, I don't want 1 over x plus 3 to be equal to 0. And then also, I don't want x itself to be 0. Do you understand this? This is coming because of this little fraction. This is coming because of the big fraction. Okay? This one is already what it is. So now here, you solve it. So we get negative 1/3. Okay? So anything other than 0 and negative 1/3 is okay. We just need to skip these two guys. So the picture for the domain would be negative 1 over 3. Here is 0. Open circle for these guys, and then everything else is green light. Okay. Questions? Yes.
Why do you have to include one answer with a negative infinity?
Say that again.
Why do you have to include one answer with a negative infinity?
Oh, look at the picture. So we're just describing these three. So how do you describe this interval?
Well, negative infinity.
Negative infinity. The way it just doesn't stop. It keeps going to the left non-stop. The way to say that is with the negative infinity. This is a parenthesis. This is not a bracket.
And then, but why not say 0, 0 then?
What do you mean 0, 0?
Because you wrote negative 1/3, comma 0.
Yes. With this guy.
Oh, okay.
So again, that's why if you write the picture tells you what to write. I want to write this part, union this part, union this part. So this one is negative infinity, comma negative 1 over 3. What's this one? It starts at negative 1 over 3, stops at 0. And what's this one? It starts at 0 and keeps going to positive infinity. If you draw a picture, the picture will tell you exactly what you need. This piece corresponds to this guy. This one is this guy. And this one is this guy. Okay. Any other questions? All right. So all we're saying here is all real numbers except -1/3 and 0. That's all we're saying. Okay. That's the domain. In other words, if you want to write this in interval notation, you can also write this in set-builder notation, which would be all real numbers x. Or, sometimes we don't even write that. We just write like this: all real numbers x such that x is different than -1/3 and different than 0. That would be another way of writing this. Okay, this is called set-builder notation. This line here reads as such that. So we're saying all real numbers except or such that x is different than -3 and different than 0. Okay, so it's everything except those two. But typically in the question they will ask you to write the answer in interval, or they expect you to give the answer in interval notation. So we do this. Understand? You can also write this if you're not being told otherwise. Okay. All right. Questions? All right. So let's see. We have done several examples containing fractions. Now let's do other types. Like for example, number 4. This is a radical example. Square root of 2x minus 5. Once again, here you take a look at the formula that you're given, and then you need to ask yourself, what could go wrong with this formula? So what can go wrong with this formula?
It can't be negative.
What cannot be negative?
It can only have a positive constant.
So what cannot be negative? Be more specific. X? Could x be negative here? Like, what do you mean it cannot be negative? What is it? It's easy. Just what cannot be negative? Just tell me the expression. I want to make sure that I can answer the question. Let's see, what's in your mind? Tell me what's in your mind. When you say cannot be negative, what do you mean? What were you thinking about?
2x minus 5.
Good. So say it. Right? So you have a square root, right? The stuff inside the square root cannot be negative. So what cannot be negative? 2x minus 5. That's what you have in there. Do you understand this? Now, let's say that we figured that out, that we take care of the problem of this guy not being negative. Is there anything else that we need to worry about in this function? But as long as we plug in something that will make sure that this is either 0 or positive, will we get an output after that? Yes, right? It'll give you a number, and then you take square root of that number, and then you're good to go. You understand this? So there's only one issue here, and he is making sure that this guy is not negative. Now here, saying I don't want, anyways, then you have to flip that interval. So here it's kind of easier to just write down exactly what you want, right? In this case, I want this to be greater than or equal to 0. You understand this? That's what it means to not be negative. So instead of writing the don't want, I'm gonna write what I want. So what do I want? Well, I want the stuff inside the square root to be greater than or equal to 0. Remember, 0 is okay. Being 0 is okay here. All right? And now there's a little linear inequality. We solve it. So as long as x is greater than or equal than 5/2, 5/2, or 2.5, then we're good to go. So in other words, here is 5/2. Do we want 5/2 to be part of the solution? Yes. So we draw closed circle. Where we go, right or left?
Right?
We go right. And anything to the right of 5/2 is good for us. In other words, the domain is bracket 5/2, comma, infinity. Okay, questions? Do you understand this? All right, so try number 5. now you see how why we spent some time, in doing chapter one, because to find these little questions, sometimes you have to solve an equation, sometimes you need to solve an inequality, and then, you need to know the techniques to do this kind of stuff. Okay, so anybody has an answer for this one? Oh, I want to hear somebody else because it's typically the same same one's talking. Yes.
I got it. Is it bracket 8/5 and comma and infinity?
So positive infinity, comma positive infinity, parentheses. Okay, well, let's see. We're gonna do it now. For example, 8/5 equals 0. Good. Now, let's see. Is 2 inside this interval? Is the number 2 inside this interval? So 8/5 is 1 comma something. So 2 is inside that interval, right? But what happens if I put 2 here? What do we get? You're gonna get negative. You're gonna get 10. So a minus 10 is a negative 2. That's an issue, right? So that means something is wrong there. So when you want to quickly check to see if your interval makes sense, pick and choose some numbers, some easy numbers inside your interval, and see if they work. Okay. Like for example, here, an easy number to pick is 2.5. You can pick 3. Put it here. 6 minus 5. Okay, we're safe, right? Here, an easy number will be 2. Put it here. We're in trouble. So you already know that something is going on here. Okay. So, all right. So let's remove it. Anything else? Let's see, if you look at your work, there was something that you forgot to do when you were doing your work. Remember, when you multiply or divide by a negative, what do you need to do? You need to flip the inequality, so you probably didn't flip. And also, yeah. Yes?
So we negative infinity, comma 8/5,
And then the bracket. Okay? So, for example, let's test this out just to see if at least it makes sense. So 8/5 is definitely an endpoint, because that's when we get 0, right? Put 8/5 here, will give you 0. But for example, let's take an easy number here, like 0. 0 is inside this interval, right? You plug it in, you get square root of 8. That's fine. Everybody okay with this? You pick 1, put it here, you get square root of 3. That's fine. So, then this gives you some confidence that maybe you're on the right track. Okay? But you can definitely spot mistakes if you do this quick check. Anyways, let's do it. So let's see, because this is square root. Let me make sure that I write down what I want. So what is it that we want here? What do we want? So we want this guy, a minus 5x, to be greater than or equal than 0, right? But otherwise, we are in trouble. Now we solve this. So you get negative 5x greater than or equal than negative 8. Now we need to divide by negative 5. But remember, because we're dividing by a negative, we need to flip. That becomes less than or equal to 8/5. Okay? So be careful. So that's your 8/5. This time we do a closed circle because it's less than or equal to, and we go left. Okay. Questions? All right. So again, two pieces of information. You see a fraction, red flag, bottom cannot be zero, right? If you see a square root, red flag, stuff inside cannot be negative. Okay. So if you see a combination of these things, then you need to worry about all of this stuff. Okay. So let's do some examples like this. For example, f of x equals 2x minus 3 over square root of x. So here, when you look at this formula, we see two things that immediately raise red flags, right? So we see a fraction, so we need to worry about the bottom not being zero, and then we see a square root, we need to worry about the inside of the square root not being negative. Do you understand this? So some things that we need to check in here. So first, so here I'm gonna have my two lists. I will have my don't want list, the stuff that I don't want, and then I'm gonna have my want list. And then we put it together. So what is it that we don't want in here? Well, I don't want that denominator to be zero. Okay, I don't want that. Is there anything else that I should worry about? Okay, x cannot be negative, but that will be thrown in the one part, because what do I want? I want x to be greater than or equal than 0. Then we're gonna put these things together, okay? So this is from my don't want list. This is coming because of the fraction. This one list is coming because of the square root. Is there anything else that we should concern ourselves in this expression? No, right? Anything else other than that is fine. So let's see, here everything is mostly solved already. Here we just need to raise both sides square, so you get x equals 0. So I need x to be greater than or equal than 0. That's because of the square root. But also I don't need x to be 0. I don't want to have x equals 0 because of the fraction. So that means we need to do some adjustments in this one list, right? So what we do is draw a picture, and then we want to put all the information. So definitely 0 here is a key player, and that's it. That's the only player that we're interested in. Now, because we don't want it, then that's it. You will do an open circle in there. We don't want this guy, so we cannot include it. And then you go to your want list, and it's telling you that it wants x greater than or equal than 0. We already know we don't want 0, so too bad, but anything bigger than 0 is fine. So you go here. In other words, what you want to do is the intersection of these two cases, okay? So this is telling you as long as x is different than 0, that's fine. This is telling you, no, it has to be greater or equal than 0. What do they have in common? Greater than 0. Do you understand this? So it's strictly positive. So what's the domain here? What's the domain? So parentheses, 0 to infinity. Do you understand this? Okay, so let's see, try number 7. Okay, so what do you get for the domain here? Anybody? So it's okay. So you almost usually don't speak too much. So tell me.
Bracket 0, comma 25,
Uh-huh.
parentheses U, parentheses 25, comma infinity.
Okay. Anybody else getting the same thing? Yes? All right, so let's see. So once again, it's very similar to the top, right? So several things to worry about. We have a fraction, so we know we need to make sure the bottom is not zero. And then we have a radical, we have to make sure the stuff inside is not negative. So we have my two lists here. So what's the stuff that I don't want? And let me have here, what is it that I want? Okay, so I don't want square root of x minus 5 to be 0, that's for sure. And then I also have to make sure that x is greater than or equal than 0, right? Which is the stuff that is inside. Okay, so that one is already taken care of. Now this one, we solve this little radical equation. So we get x is 25, okay? So we need to avoid 25, and we need to make sure that we plug in non-negative stuff, okay? So putting this together, so you look at the intersection. Now, what are the points that we see? So we see 0, so we need to have it in there. And we see a 25, we need to have it in there. So remember, we don't want 25, and then we want 0, and anything to the right of 0. Now, because we need to skip 25, then you need to understand that it's this piece, and then together with this piece. So we have one piece, skip 25, and then the other piece. You okay with this? Because 25 itself is okay for the square root. Square root doesn't mind the 25. But then the fraction tells you, wait a minute, 25 is bad. Okay? All right. Questions? Okay. So let me show you how, in a sense, we can pack everything that we did in chapter 1 in one single question like this. Okay? Or almost everything. Otherwise, we'll make it slightly long. So I'm going to borrow a function from above. Let me actually call it g. Well, okay, let's do 8, and then, because we already have a number 8 on top, and then I'm going to write down the problem. Okay, how about this one? Let's see, this one is quick. Who can tell me what's the answer to this? Yes?
All real numbers.
Very good. So here the domain is all real number. So negative infinity to infinity. Because again, you see a fraction and you say, well, I don't want the bottom to be 0, but that's never going to happen anyways, right? Because here you have x squared plus 1. This will never be equal to 0, right? This is 1 plus something that's either 0 or positive, so this is going to be greater than or equal than 1. So we never touch 0, so we are fine. So here, if you want, you can say, okay, I don't want x squared plus 1 to be 0, but this means x squared is equal to negative 1, so this has no real solution. Okay, so this will never happen, we don't have to worry about it. So you're free to plug in whatever you want. Do you understand this? Okay, good. So how about this one? Let's see, let me borrow one of the functions from before. And then let's throw in square root here. And let's do plus another square root. And then I'm going to do absolute value of 3x minus 5 plus 7 over absolute value of 2x minus 7 plus 3 and minus 3. So here is a function. Let's find the domain of this function. So let's see. Let's try to figure out what are all the things that we need to do. Okay? Or what are all the things that we need to worry about. And let's see. Let me put a minus here. Because with a plus it's easier. So actually we're gonna analyze it with a plus, but then I'm gonna switch it back to a minus. Okay, so let me leave it with a plus because it's in fact, let's put an extra guy here. Now we have our plus. And if we want to be more fancy, we can do this. That way we pack everything we want. Okay, so here is a big function. Whatever, doesn't matter. The point is that, when you plug in a value for x, you put it in here, then you will get an output. You evaluate each of these little expressions, you add the three numbers that you get, and then that's going to give you an output. In other words, each of these guys are functions. The sum of two functions is a function. So here we're adding three functions, you get a function. So our job is to find what's the domain of this function. Really, the exercise that I want you to do, or to tell me, is to write down our list. So you need to tell me what is it that we need to worry about here. So what is it that we don't want, and what is it that we want. And then it's just a matter of solving all of these and putting the information together. Okay? So, just scan one by one. Just scan, focus on this piece. Once you're done with this one, move to the next one and solve. Okay? Instead of trying to look at the whole thing at once, just do it little by little. So let me write down my list here of what we don't want, and then here I'm gonna put my list of what is it that I want. Okay, let's see. Let's look at the first one. What is it that we don't want from the first one? So look at the first term. What do we need to worry about? Yes?
Plus 1 being greater than or equal to 0, and...
Okay, that's what we want. So what is it that we don't want?
Oh, we don't want x to be 0 or 1 over x plus 3 to be 0.
Okay, so this is something that we need to worry about, and then let me leave a little space here, and this is something that we need to worry about. This is according to the first one, yes? Now let's see, is there anything that I should enforce in the one list coming from the first one? So what should we enforce?
2x plus 1 being greater than or equal to 0.
Exactly, because we see a square root there, we better say, okay, I need this to be greater than or equal to 0. You okay with this? Now let's keep adding. Now let's move to the next one and repeat. Let's see, the next one. Is there anything that we don't want? Yes? It's easy. I mean, it's the same idea as what we have been doing. So what we don't want from the next one? Yes?
We don't want x to equal 0.
We don't want, I'm talking about this. Does this have a problem with, okay, so why do you say we don't want x to be 0? So we're looking at this one now, okay? So later we're gonna solve all the things that we write. So let's just make sure that we get all these down, okay? And then we solve each of the little equations. So we're done analyzing the first expression. Now we're moving to the second one. What is it that we don't want from here? Yes?
The absolute value of 2x minus 7, right? Minus 3 to equal 0.
Exactly. We don't want this guy to be 0, right? So we throw it into our list. So we don't want absolute value of 2x minus 7 minus 3. We don't want this to be equal to 0. So that's something that we need to figure out. Do you understand this? Now, is there anything that we want to ensure coming from this expression? Somebody else tell me. Is there anything that we want to make sure that happens coming from here? Yes?
The square root of 3x minus 5 minus 7 is greater than 0.
The square root or the stuff inside the square root?
Yeah, something that is greater than 0.
So the absolute value, right? So we want to make sure that this guy is greater than or equal to 0. Remember, 0 is fine in here. So we want to make sure also that the absolute value of 3x minus 5 minus 7 is greater than or equal than 0. So we're going to be solving all of these little things now, but let's make sure that we get our list. So this, once we do all these things and we do the intersection, etc., we are taking care of the first and the second. Now we need to go to the third one, right? Make sure that we are fine with the third one as well. So, is there anything that we don't want from the third one?
X plus 1 is -1 and positive.
So we don't want square minus 1 to be 0, right? So we need to throw that in here. Okay, let me put it here. We don't want this to happen. And then, is there anything that we would like to enforce? According to the third expression, is there anything that we definitely want to happen? I mean, this is automatic. You see square root. What do you need to ensure? When you see a square root, what do you need to ensure? That the stuff inside is not negative, right? So you want absolute value of 2x plus 5 plus 7 to be greater than or equal than 0. Do you understand this? So once we figure out all the things, so on the red part, these are all the stuff that we don't want. In the blue part, this is all the stuff that we need, that we want, that needs to happen. Okay? Then we put this together and then we get a domain. Do you understand this? Okay, so then let's do it. So let's see. Okay, x equals 0, that's already there. Then, I mean, we already did these ones. So here we get 1 over x is -3, so -1 over 3. So 0 is something that we don't want. -1 over 3 is something that we don't want. Now let's figure out this other 2. So this one is an absolute value equation, right? So to solve it, we need to use the techniques that we have discussed. So move the 3 to the other side, and then we get 2 equations. Who can tell me what are the 2 equations that we get? So either 3 or -3. Yes? Remember, there are only 2 choices for the stuff inside the absolute value. It's either positive or -3. Okay? Otherwise, the absolute value will not be equal to 3. So over here, we get that this is 10. So we get x is 5. Over here, we get 4. So x is 2. Okay? But once again, this is part of the don't want list. So these are stuff that we need to avoid. Okay? This is stuff that we need to avoid. And then lastly, for the other equation, what is this? What are the solutions for that remaining equation? Square equals 1. So we have plus or minus 1. Okay? So we need to avoid 0. We need to avoid -1 over 3. We need to avoid 5. We need to avoid 2. We need to avoid positive 1. We need to avoid -1. Do you understand this? All of those numbers are not good for our function. Now, let's actually see what is it what's good. So what do we want? What's good for our function? We know what's not good. Now let's see what is good. Because remember, this is not the whole story. There is all stuff that's not good. It's just that whole story is encapsulated here. Okay? But for example, -1,000 is not good. Why? Because it would violate this guy. It's not showing up in here, but it will be taken care of by this portion over here. That's why you need to do everything. Okay? Okay, so what do I want? I want 2x plus 1 to be greater than or equal than 0. As you know, this means x has to be greater than or equal than -1/2, right? So we need to make sure that that happens. Now, before I move on to this one, what's going on over here? Is this really a concern? So what is this giving us? So this means that 2x plus 5 is greater than or equal than -7. So what's the answer here?
All real numbers.
All real numbers. So this is always true. In other words, what this means is that as far as this radical is concerned, x can be whatever you want, because you will never get something negative down there. Do you understand this? So this guy doesn't really impose any restrictions. So really, the issue comes down to these 2 guys. Okay? This one doesn't matter. Now, if it would have been, let's see. if it would have been 7 minus this, okay? If it would have been, instead of being this plus 7, it would have been 7 minus the absolute value. Then, let me just write down. I will erase it, but if it would have been 7 minus the absolute value, we would need that to be greater than or equal than 0, right? So that would mean then that the absolute value will have to be less than or equal than -7. Do you see that? No, wait, 7. That's not what I want. I want it to be minus. Okay, so I guess like this. It's just that I wanted to understand something. So imagine that it was -7 minus the absolute value. Okay, so that would be the statement that absolute value of 2x plus 5 is less than or equal than -7, because you just move this guy to the right hand side and then reading from right to left, it will be absolute value less than or equal to -7. Okay. Now at this point, what's the solution here?
No.
The point is that this will never happen, right? So this is false, so there is no solution. So if something like this were to show up, that means actually that this function has no value here. Even though these guys would be okay for some values and so on, this one will be telling you, wait a minute, there's nothing you can plug in here. Do you understand what I'm saying? Okay, so be mindful of that, because you will have a huge expression, but then there could be one little term that tells you this expression is meaningless, because you cannot plug it in. Okay, if this happens, this is telling you that you cannot plug it in. Keep that in mind. Anyway, that's not what's happening, so get rid of that. Okay, so now that we solve all the little equations and little inequalities, no, we missed little. So let's do that one. So this is absolute value of 3x minus 5, greater than or equal than 7. Now remember, this is a greater than or equal to, so this becomes an OR type inequality. So either 3x minus 5 is less than or equal than -7, or 3x minus 5 is greater than or equal than 7. And we solve it. So here we get -2, so -2 thirds. And here we get 12, so 4. Okay, so let me box the things that we want, highlight the stuff that we need to consider. So this, and then we also need to consider this, and this. Okay, so let's put all of this information on the same picture. Okay. So let's graph the domain. All right, so the first thing that you're gonna do is we need to write, all the numbers that we see in both lists, we need to, we need to put them. So let's see, I see what's the smallest number from this list. So I see a -1/3, -1/2, -2 thirds, and -1. So -1 is the smallest, right? So I'm gonna have a -1 over here. Then we're gonna have -2/3 over here. -1/2. Then we have -1 third. Okay. Let's see. This, that one, this one. Now we need to do 1 and 2 and 4 and 5. 1, 2, 4, 5. So let's make sure that we have everything. So that's 1, 2, 3, 4, 5, 6, 7, 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8 numbers. Okay. So now, once we have all the numbers, where they're supposed to be, we need to decide what we want, what we don't want. So from these numbers, let's just go one by one. Do we want -1? Don't want. Do we want -2/3?
Yes.
Okay, so one piece is telling you yes, but there could be other pieces that tell you no. So just to be safe, what we should do is definitely write down what you don't want. So do open circles on what you don't want. Then those that you may or may not want, the reason why I'm saying that is because if you look at this, it's telling you yes, -2 or 3 is okay. But it's okay because of this. For example, what's happening is that this one is telling you, wait a minute, you have to be greater than or equal than -1/2. So it's going to be left out. Because you see, the first inequality is telling you that you need to stay to the right of this. That would not include the -2 or 3. You understand what I'm saying? So the problem is that if you put a closed circle here, you will believe that will be part of your final solution, and it may not be. Okay? So right now, let's just definitely put what we don't want. And then if we want something later on, we include it. But the stuff that is in red, we definitely don't want it. So that stays open all the time. So let's focus on the red stuff. So I don't want -1. I don't want 1. I don't want -1/3. I don't want 2. I don't want 5. Yes?
You messed up, x equals 0, x can't be equal to 0.
Where is this? Oh, 0. Ah, good. Okay, I'm sticking in here. Yes, that's a very top one over there. So, you don't want this either. Okay. Are we good so far? Okay, so this is definitely the numbers that we don't want. Now, the others, we will see whether we want them or not. Okay, so we're done with the red list. Now let's go to the blue information. So this one is telling me that x has to be greater than or equal to -1/2. So that means this to the right. Then this one is telling me that x has to be less than or equal than -2/3. Let me use another color for that. Or greater than or equal than 4. Yes? That's what that told me. And that's it. We don't have anything else. So now our job is to look at this picture and see the overlapping. So among all of this, what does every piece have in common? So let's see. Can you tell me something that every piece will have in common? I don't want to start sharing stuff because then it will look too messy. So it's easier to just look at the picture the way it is. So for example, the red, this is stuff that we are skipping. So let's ignore that for a second. So let's look at the blue and the green. What does the blue and the green have in common? Yes?
Greater than or equal to 4.
Exactly. So notice that we have green over here, but there's no blue, right? So this is okay for the green, but it's not okay for the blue. Over here, the blue begins, but there's no green until this point. So you have to ignore this as well. Everybody okay with this? Starting at 4, we have green, we have blue. So that means this part over here is fine for both of those. Yes? Now, there is also something else that we need to worry about. So 5 is in here, and it's okay for both of these guys. But 5 came from a red list. It's something that we didn't want. So we need to skip 5. So what would be the domain in this case? So it would be this together with this, right? So domain would be 4, 5. So bracket of 4, parentheses of 5, union 5 to infinity. So parentheses. Did you understand this? So again, the point is just do it one at a time, little by little, and then once you have all your wants and don't wants and so on, throw everything on a number line, and then start dropping everything little by little, and then you will see what you should consider or not. Okay? Remember, you always want the intersection here. You want to see what's okay for everybody at the same time. Okay? All right. Questions? Yes?
What's the green for again? Like, what does it stand for?
What
What's
is,
the green for? Like, what does it stand for?
oh, the green is this.
Oh.
You see, less than or equal than -2/3 or greater than or equal than 4.
Why don't you use blue?
because I already have blue. So if I use blue, then right. So I use another color, so it will be easier for you to see when two different things overlap, right? Because I already have used blue already. Okay. Good. Any questions? All right. So that's the story about domain. Of course, here this is I'm just exaggerating things a bit. This is really an exercise on getting the skill of figuring out stuff that you want, stuff that you don't want, and so on. Okay. But don't expect us to be doing stuff like this. Okay. Things from above is fine, but this is just to make a point.